Okay. Hi again, it's Jim Lindeman, and we are embarking upon a rather interesting topic, but one that's kind of involved. This is actually my second time through, so hopefully I can talk a little bit faster. It hopefully depend upon you to use your notes so that we don't have to spend as much time as I had originally, which was much too long. Okay, cosmic evolution, beginning of the universe. You have, Anna's Bible says God made the sun and the moon and placed them in the sky. That's pretty much without saying, how do you mean? Well, he made the heaven and earth, didn't he? Yep, says he also made the stars. No way. What do you mean, no way? Are you serious? The scaffolding alone would be an architectural nightmare, trying to hang all of those stars up there. This one actually, though, is one I think has a lot of meaning for what we're going to be talking about. You have Sarge talking to, I forget what his name is. Anyway, you know Parkinson's law? Yeah, work multiplies to fill up the available time. Well, here's Beetle's law. Nothing multiplies to fill up the available time. We're going to do an awful lot of talking about nothing in the beginning part of this film. Ex nihilo means out of nothing. And so you have God created ex nihilo, or you have evolution created ex nihilo. So how do these both come at the concept of the creation of the universe from a little bit different point of view? I'm just going to move this a little bit. There you go. All right. So, oops. All right. The idea that God created ex nihilo is considered a foolish belief, that by declaration God said, fiat, by spoke the universe was created, where there had been nothing, no pre-existence, based upon the Creator's description of what he did, and there's a whole bunch of Bible passages there. A wise mind was required to plan uniformity and consistency, or what I call monotony. And what I mean by monotony is that proton, neutron, electron, subatomic particles are all exactly alike throughout the whole universe, everywhere. That's what is anticipated, that is what is based upon whenever you have science trying to determine the farthest galaxy or whatever it may be. It is assumed everything is exactly the same, operates the same, that the atomic spectrographs from distant galaxies are going to be the same everywhere, that gravity and other forces will operate the same anywhere, so that gravity being one of the most key elements in the development of the universe according to evolution, is that it can't be something that is going to be changeable depending upon where you look in the universe. So you have this, what I call monotony, predictability, and testability to the intricacy of the universe. That somehow what we do know here, we can apply and check out as we take a look at the stars and everything else in the universe. Evolution, on the other hand, created also ex nihilo, and this is the scientific belief. The singularity of nothing created the universe. No testable physics establishes this conjecture, and it's a conjecture. Completely random action established uniformity, consistency, or monotony, predictability, and testability. In other words, complete random. What happened here randomly happened also everywhere else, so that your neutron, your proton, your electron, everywhere is the same thing, same size, same weight, same attraction, and everything else like that. That the atomic spectrograph of helium or hydrogen is going to be exactly the same simply because of random action throughout the universe. Big Bang cannot be duplicated in a laboratory, obviously. What creationism says, outside and above the universe, Creator came and put it all together so that we can depend upon it. Evolution says the universe created itself, even willed itself into being. One of the things that is kind of interesting as you take a look at the evolution of the universe, an evolution period, is that it almost has a personality of its own. It almost has a sense of will, a sense of direction, even though they try to say, no, it's not true. We'll talk about that a little bit more as we go along. The biblical concept of nothing is that there's nothing, not anything, no single thing, non-existent, without quantity or magnitude. The evolution concept, I borrow an idea or a description from Orwell's 1984, and it's to this idea of nothing. In Orwell's 1984, he's talking about the concept of black-white. It's defined as follows. This word has two mutually contradictory meanings. Applied to an opponent, it means the habit of impudently claiming that black is white in contradiction to the plain facts. Applied to the party member, it means a loyal willingness to say that black is white when party discipline demands this. But it means also the ability to believe that black is white, and more to know that black is white, and to forget that one has ever believed the contrary. This demands a continuous alteration of the past, made possible by the system of thought which really embraces all the rest, and which is known in newspeak as doublethink. So you have the word nothing. Doesn't really mean nothing if you are an evolutionist. But everywhere else the word is used, it means simply no thing, nothing. So you have, again, as a comment on Orwell's 1984, the ability to blindly believe anything regardless of its absurdity can have different causes: respect for authority, fear, indoctrination, even critical laziness or gullibility. Orwell's black-white refers only to that caused by fear, indoctrination, or the repression of one's individual critical thinking. To know black is white, rather than caused by laziness or gullibility. What you have is a language game playing put down of the non-expert. So if you're not in the scientific know, and you're the person that's sitting out there in the street, well, if you don't know what I'm talking about, then of course that's because you don't have the capacity. But we know that when we talk about nothing, it doesn't really mean nothing. Well, okay, you just have to know what I mean. And I have a problem with that kind of attitude, no matter what it is, whether it's in science or theology or anything else like that. When you have that sense of a put down, we use these words because we know what we're talking about, but you don't. See, you're somebody who's stupid. I have a problem with that. Okay, laws of gravity. All right, you have poor Irwin here, and he just can't keep his feet on the ground. And Broomhilda says, the ignorance of the law of gravity is no excuse, Irwin. Well, gravity is going to play a big part in what we're talking about. Well, say for instance you have the expanding Big Bang plasma ball, and out of this singularity of nothing, it explodes. And now you have all of this that's coming. But, okay, as you have this big bang of plasma, what gives it the ability to congeal down into atoms and all the rest? Now, yeah, we can think about that, but now we got to ask, what would be the mechanics of that? Any attractive force like gravity would exert force to and from every direction simultaneously, canceling each other out. So So there's not going to be where all of a sudden you're going to have things all attracted together, because you're going to have the same attraction being pulling them apart at the same time. So if you have this plasma ball, how do you get where you now begin to have atoms, and then you're going to have stars, and you're going to have galaxies and all the rest? Where is that going to come from? There's no graininess or clumping to eventually turn into atoms and so forth. Now, if you have smoke, like for instance the smoke from a cigarette, all of a sudden you have what seems to be a rather direct beginning. Suddenly it goes all wild. But that's only because there are collisions with something that's pre-existing. Pre-existing air causes it to go into these kinds of change of directions. With plasma, there are no outside forces. There is nothing. No collisions with pre-existing substances to create a swirling motion that would now become, well, an atom, a proton, a neutron, a star. Where would these forces come from? Cosmic microwave background was thought to be the telltale mark of the Big Bang, and that supposedly as it has cooled down over the billions of years, this is at the level it should be. But the problem is that there are no uneven distributions of the initial temperatures to create fluctuations in the expansion. From all directions, it's very uniformly distributed. In fact, there's not even any shadows. And so what you have is that there is nothing that should have made this plasma ball congeal down into little dots, or into universes, or into galaxies, or anything else like that, because it identifies the fact that the expansion was completely homogeneous. There was no unevennesses to create now the possibility of things forming. Angular motion. You know, this is obviously this is not exactly the way it looked, but it's going to be useful for a demonstration. To change a direction, you need a force. You need something that's going to now add on a different direction for whatever it is that's happening. A new force from somewhere to change direction of the results of the Big Bang, to bring about rotational motion. Not just that there be spin, but there be sufficient velocity to the spin. The opposite spins of proton-neutron. The question here is that you get into the atom, and you have the spin of the proton and the spin of the neutron, and they're in opposite directions. So what's playing in the forces to create opposite directions? You can understand perhaps if there was a swirling or something else like that, and everything is going to be the same. But everywhere in the whole universe, everywhere, whatever this force was had to act everywhere. And it had to create it in such a way that things spun in opposite directions. The proton spin crisis, the spin of quarks, were supposed to carry the spin of the proton, but only could provide about 25% of it. And then you got the gluon, and that's together, all together between the quark and the gluon, was only 70%. So where did the other 30% come from that creates the spin that we can observe now? None identify where the spin first came from. Yeah, okay, they got the spin, and it's obvious. But the ultimate, Dr. Stuart Ross Taylor, the ultimate origin of the solar system's angular momentum remains obscure. Gravity does not cause a spin, but rather that things collapse in upon itself. There is no angular motion to gravity. It's, I'm pulling you to me. And so even that does not give you enough of the ability to say, okay, now you have a spin or a cause for the spin. Everywhere in the universe, the particles making up the atoms are expected to be identical. Hydrogen atom, for instance, the hydrogen atom, and therefore its light absorption and redshift. So in other words, I can depend upon what I see in a spectrograph from a distant galaxy or a distant star. Therefore, random evolution of such particles would seem very stretched. I mean, everywhere in this vast universe that you would have identical results everywhere, you do have a question as to how then, what's the mechanics of making that happen if it's merely, purely, only random action. I can understand random action localized, but not on a universe scale. Gravity problems, no solution to planet formation. So if you have here a sun that explodes and out comes this nebular gas, and then you have, basically you can't see it so well, but a lot of little sprinkles, little atoms all over, and that supposedly now these atoms begin to attract each other and they start to congeal to a little bit more, and then it gets into a cloud, and that cloud congeals even more into a sun and a planet. Now the difficulty is that gravity is not strong enough to attract atom to atom. So if you're going to start out with this, how do you get them to get to that point? The mass must be about 10 meters in size to have enough gravitational pull. So how do you get those original atoms together to have that much mass to be able to create that much pull? Now the other problem with this is that as you start getting into this level, you have gas pressure pushing out while you have gravity pulling in. In a nebula, gas pressure outward is normally too great for net gravity to collapse the cloud. So how do you get it down to this point, much less down to that point? Okay, gravity is a centripetal force which pulls it in when over the centrifugal force of an already rotating cloud, and yet not also pull in planetary disks. In other words, if this is going to start pulling together and to form into that, how does it not act upon that mass and pull it together and make it one? How does gravity have such selective ability? Why isn't our gaseous atmosphere condensed? So in other words, if the mass is enough to pull together this cloud into such a tight mass as the Earth is, then how do we still have an atmosphere? How come it hasn't pulled all of the gas and everything else like that into a solid? Because the Earth should have enough mass to make this happen, then how come some of it isn't cooperating? Birth of stars seems to require cosmic shock waves of sorts, as from an exploding star. But where does the first stars come from? How did they form? How did they get there? How did they now get past all of this into that? Yeah, a shock wave can possibly do that, but where did the shock wave come from for the first round of stars? Accelerating expansion, dark matter and energy. Supposedly 4% of the matter of the universe is visible. It's called baryonic, ordinary matter, the stuff of stars and people. There is supposedly a 30% of the matter, or of the substance, if you will. Okay, we'll say matter and energy. Let's say the substance of the universe. 30% of it is dark matter. 7.5 times greater than the baryonic, according to the CMB, the cosmic microwave background radiation. Dark matter comes in two states, hot and cold. It is undiscoverable matter because it has no qualities except only that it provides gravity. You can't see it, touch, feel. You can't, nothing. There is no way that supposedly you can discover what this dark matter is, but it provides the needed gravity for the theory to work. the universe, okay, it's 66%, in other words, twice as much of the substance of the universe is unobservable dark energy. Why? Because supposedly what's happening is the Earth expansion is accelerating. And they can't figure out why. What is the force that's acting on the universe to make it speed up? And so this was postulated in order to explain that. So twice as much is this dark energy to accelerate the universe, a tremendous anti-gravity energy of, again, no unknown source and character. There's no way you're going to know what it is. You know where you're going to find it. There's no way you can test for it. They've tried for 40 years, but that's okay. It exists anyway because, after all, it's a convenient thing to explain things that cannot be explained according to the theory of evolution. Well, an open letter to the scientific community, originally published in New Scientist, and this is a journal, a science journal. So this is not just a little junky backwater rag. This is something that is peer-reviewed and then published as an authority or authoritative source. It was signed by 34 secular scientists, further co-signed by 218 scientists, engineers, 187 independent researchers, 105 others. The Big Bang today relies on a growing number of hypothetical entities, things that we have never observed. Inflation, dark matter, dark energy are the most prominent examples. Without them, there would be a fatal contradiction between the observations made by the astronomers and the predictions of the Big Bang theory. In no other field of physics would this continual recourse to new hypothetical objects be accepted as a way of bringing the gap between theory and observation. It would at least raise serious questions about the validity of the underlying theory. Now, this is secular scientists. This is not creationists saying this. These are scientists who have a commitment of making God not a part of this, and they're saying there's a real problem as to this major theory that seems to rule science, that they are really, really questioning what's going on. One of the things to explain why the cosmic microwave background radiation would be so smooth is that that it would be distributed in all directions with no shadows. The hypothetical fudge factors, such as a faster than light localized inflation bubbles, are added to the Big Bang. Now the thing is that there's no idea as to what that is, or how that came into being, or how you started, or how you stopped it. So already, so you have this wonderful extra added on to the Big Bang theory, but there is no content, there is no substance to it. Or the speed of light, radiation, may have been much faster in the past, and yet you have the idea that the speed of light being a constant to Einstein's E equals mc squared, c being the speed of light. Okay, getting to that open letter. But the Big Bang theory can't survive without these fudge factors. Without the hypothetical inflation field, the Big Bang does not predict the smooth isotropic cosmic background radiation that is observed, because there would be no way for parts of the universe that are now more than a few degrees away in the sky to come to the same temperature and thus emit the same amount of microwave radiation. Inflation requires a density 20 times larger than that implied by the Big Bang nucleosynthesis. In other words, the beginning of the atoms of hydrogen, that it just doesn't have enough. They can't come up with enough to give it that kind of an enormous amount of material to make an inflation work. The horizon problem. The precisely uniform temperature challenges the early universe temperatures expected to be very different at different places in space due to the random nature of the initial conditions, without enough time to even out the temperatures. In other words, you're going to have differences of temperatures if you're going to have planets or anything else like that form. Something's going to have to make ripples in the plasma. And the thing is that it doesn't work. For it to finally homogenize down to the same level to everywhere, there isn't enough time. Now for the Big Bang envisions the shell of plasma from the exploding singularity to be very much like a balloon, and that everything is on the surface of the balloon. Therefore, the observed universe is only what is found in that shell, that there is literally nothing in the center. There can be no center, only empty space, if indeed it to be described as space. What we call space around us is occupied by matter and energy. Would there be anything left in the void in the center of the balloon? Well, if it's all expanding, why would anything be left behind? Because the force of the explosion would push everything out. And so when the big crunch comes, and that's when supposedly that the universe would have enough substance, mass, to now make it congeal back down to a center, the gravity acting through the center of the balloon would become negligible. So in other words, from this side, would the gravity really have any depth, any strength, by the time it gets to the opposite side of the balloon? The distance would be far too great. Its effect more likely would be lateral, in other words, going across the surface. But then that would force uneven compression, and likely not necessarily return to the singularity. Observation tells us a different story than this. The universe's center, redshifts of galaxies, are clustered into distinct groups as if in concentric shells rather than random, centered on our galaxy. In other words, the redshift distances, when you plot them out on the graph, they come to bands. That at this distance, there's a band of stars. At this distance, there's another band of stars, and so forth down the line. You would not be able to see this unless you were at the center of those shells. Otherwise, you would end up with such a random assortment here that there would be no distinctiveness available. The fact that you can see that means that the observer, us, has to be very close to the center. And that may be one reason why you have the spreads, is because we're not quite at the center. The center of the universe being probably the center of the Milky Way. Observed radiation from quasars is polarized in a given direction. In other words, that even with quasars, there is a sense of coming to a point, polarized. That the light is shifted to a certain direction. Galaxies have a preferred direction of alignment. One of the questions is, how come it's such a flat disk? If it's an explosion, there should be, if it's an expanding balloon. The problem is that the universe is pretty much kind of a flat disk. Evolution delights in saying Galileo removed mankind from being in the center of the universe. It seems that the redshift restores humanity to that position. Biblically, this planet is the planet that the Creator stepped foot on. Something special about this planet just by the fact that God would consider this place to be where He would become one of us. The humans made in the Creator's image. The humans the Creator bound His life to. The humans the Creator became one of. Yes, this world does step into the middle of the whole universe. And the redshift seems to indicate that there's reinforcement to that idea. By inserting a few unprovable assumptions as your starting point, you can end up with virtually any model you like. The Big Bang assumes that the universe has no center or edge. Not only is this not proven, some of the recent research on redshift patterns have badly damaged its credibility by indicating that our galaxy is at or near to the center of the universe. Dark matter and energy. This is fun. Core of the galaxy rotates faster than the arms. In other words, if this is a disk, okay, and here you have the core of the galaxy, and you've got the arms, and as would happen is that the arms are getting spread out because of the speed of the rotation. The galaxy should fly apart after billions of years. And yet it is assumed stable even after all the alleged time that the galaxies have existed. Like the Milky Way galaxy, that we are pretty much stable at the distance to the center. Therefore, if you're going to do that, you're going to need a lot more energy to keep that centrifugal force from pushing everything out. You're going to need a centripetal force that's constantly pulling everything back so it doesn't get too far away. The only property of dark matter, the supposed substance, the only property it has no visibility, it has no other kinds of things, it's not hot, it's not cold, or anything else like that, cannot be observed or tested. So here you have a substance whose only attribute is gravity. Why? Because it needs to explain why, after billions of years, you still have galaxies. Yet dark energy, which is twice as much as the dark matter, is supposed to be pushing, driving the universe apart. So here you have twice as much of a source pushing the universe apart. Half of that is pulling it to maintain this. You still end up with, how do you explain then that the dark energy doesn't win after all this time? I mean, it's wonderful to postulate all these wonderful different types of elements. But when you start putting them together, how does it work? Okay, the basic prediction about the structure of cold dark matter and dwarf galaxies. Again, dwarf galaxies, they need an awful lot of gravity to help pull them together and make them exist. So it's composed up to 99% of dark matter, 1% of normal matter like stars. The density of dark matter should increase sharply toward the centers of these galaxies. In other words, if you're going to have gravity, the gravity is going to attract other gravity, and you're going to end up with a much solider mass of gravity, or mass in the center. Yet if it really exists, and apparently is rather evenly distributed uniformly over a relatively large region, several hundred light years across. In other words, if there is such a very powerful concentration of gravity, how come you don't have other kinds of evidence that gravity would require to have happen? The data, if a dwarf galaxy were a peach in the standard cosmological model, is that we should find a dark matter pit in the center. Instead, the first two dwarf galaxies we studied were like pitless peaches. So if the dark matter is required for a galaxy to exist like this, maintain this existence, then how come these galaxies don't have anything that suggests that kind of concentration of the gravity force? Okay, star formation. Okay, so you start out with the interstellar nursery. Star begins to form in a nebula, cloud of interstellar hydrogen gas and dust. The gas and dust compress due to gravitational forces, forming a slowly rotating globule. That's wonderful, except that you have a problem. The problem is what's called hydrodynamic equilibrium. The outward accumulated pressure due to internal heating of the compressed cloud equals the inward force of the mutual gravitational attraction of all matter in the cloud. Remember when I had the two arrows, the gravity pulling one way, but the gas pressure is pulling it away. No further contraction can occur unless something else is introduced to overcome this limitation. The energy must be radiated away, in other words, the heat, to cool it, which would require an indefinite period of time. If matter density is below a certain value, cooling is impossible. One mechanism to cool down the cloud might be molecules in the cloud colliding and radiating heat away. But the Big Bang made only hydrogen with a little helium. Helium can't form molecules. The only molecule would be molecular hydrogen, H2, easily destroyed by ultraviolet light, and needs dust grains, which require heavier elements, in order for this molecular hydrogen to form. Atomic hydrogen just can't do it. Abraham Loeb of Harvard Center for Astrophysics says, the truth is we don't understand star formation at a fundamental level. In other words, yeah, you can postulate all you want and say, oh, this is a very romantic way of being able to come about doing it, but really when you get down to the mechanics of it, you don't have any mechanics. Shock wave from supernova compresses the nebula, but where did the first stars come from? Or propose much more dark matter. In other words, that you're proposing that there's 85% more dark matter at the centers of these things so as to be able to have that gravity to go beyond that hydrostatic pressure limitation. But then you have the question of, but where does the dark energy fit into all of this? Or is it on a vacation until whenever it's needed kind of thing? I mean, how do you have both filling the universe at the same time and not contradicting each other or counteracting each other? Okay, next step, you have gravitational forces overcome the gas pressure and the globule collapses. Cooling occurs and the spin increases. The law of conservation of angular momentum is that, for instance, as the nebula contracts to the center to form the sun, the same effect is as the spinning skater who draws in the arms and therefore goes faster and faster and faster. The only problem is the sun should therefore spin very rapidly. The reality is the sun spins very slowly. And the planets on the outside, which should be slower, are actually spinning very rapidly around the sun. So in everything that's being predicted, you have the opposite happening. Spin, pressure, temperature increase, the globule differentiates into protoplanetary disk, which may become planets, and central core, which will become a star. The nebular hypothesis. But the clouds are too hot, too magnetic, and they rotate too rapidly. The contraction produces effects that tend to make the formation of planets impossible. Dark matters everywhere except where it's not needed. How does dark energy enter in? Or is it also only when it's needed? No force apparently is greater than gravity, since it speeds up the expansion. Or its force, rather, is greater than gravity. It seems to be an anti-gravity force. So how does that play into all of this? Or do we just neatly forget about it because it won't work, won't make the theory work the way that is wanted? Stellar sequences. Can stars really sequence into 3 or more generations? So you got the Big Bang, and you got hydrogen and helium being formed, and now you congeal into a star. The star has common elements, it explodes, and you have the primordial soup of space. The only question that I have is that it took all of this to form a star. Now, when you have the second star come, you're not going to have all of this. You're only going to have perhaps a small segment of that star. And yet that is going to be adequate enough to start another star. Okay, so maybe you pull in hydrogen and everything else like that. When a star spews out explosion debris in all directions, which is dispersed into the vast emptiness, distances of emptiness, thereby providing scant material per cubic meter of space, how then is there enough material to form a second star? I really, there's a question. Well, okay, maybe there's hydrogen there. But hydrogen would only create a star that would start giving you common elements. What you want is enough debris that would now create the heavier elements. You'd have carbon and everything else like this, but you need to also have like the iron and so forth and the heavier elements, the metals. And then it explodes. And again, you still have a small segment of that might then become the Earth with its sun. So, in the second star, having absorbed all the degree in the area, dispersing in all directions, having enough material to form a third star in planets, observing the remains of novas and supernovas and their dispersion clouds. What are the physics of those clouds forming yet another star? Is there really enough material? Or do you have to just kind of sidestep that like you would dark energy and its way of defeating dark matters being able to form a star? Timeline until the sun. Oh, okay. The sun supposedly takes about 10, 12 billions of years, well 11 billions of years before it sheds its first level, its outer shell. So, and supposedly the sun is about right there. Okay, so that's what we have to look forward to in terms of billions of years. Okay, now let's take this in terms of the age of the universe. Now, basically working model has been about 13.8 years. You can get up to 20 billion years or however. But let's just stop for a moment. It takes the Earth, or the sun rather, 11 billion years to get to a point where it sheds its material. The Earth, or the sun rather, will have started about 9 billion years, thereabouts, maybe 14. In that period of time, you have had two stars, at least two stars, who have gone through the full cycle. Well, if that's true, if the 13.8 billion years, then this star will have had to go through its cycle in basically about 4 to 5 billion years. The second star would have to do the same thing. And so what you're talking about are life cycles of stars that would have to have been only about 5 billion or so years each to finally get to that point where you'd have the material to build the sun and the earth and its planets. So at least two generations of stars had merely 3 or 4 billion years each, or 5 maybe, to have occurred to provide the heavier elements we find on the earth. Well, if you're looking at about 5 billion years, we haven't got much time for our sun then. If that's what has happened, and that's the evidence of what has happened, then this whole theory of how long the sun has got actually is a lot shorter than we think, than that would be thought. Then the sun is overdue to the same shedding of its elements. Notice that the entire life of a star is an aging process. Main sequence, which is what that is, to red giant to white dwarf. Instead of stellar evolution, it might be better called stellar decay, degradation, or degeneration. Computer studies have concluded that each stage of a star lasts for millions or billions of years depending on the star's mass, but in the recent creation view, there has not been enough time for such change. And some observed star changes appear to be much more rapid than computer models suggest. For example, there is evidence that the dwarf companions to Sirius formed from a red giant in just 1,000 years. Other stars have also shown unexpected color changes, indicating that the aging process of some stars may be much more rapid than generally believed. And so maybe we don't have the luxury of what is being talked about for our sun. Our sun, faint sun problem. As the core of the sun changes, the thermonuclear reaction in 4.6 billion years would mean that it would have brightened 40%. Since life began 3.8 billion years ago, it would have brightened 25%. 25% increase should elevate the temperature 18 degrees centigrade. The current average temperature is 15 degrees centigrade, which means 3.8 billion years ago, the average temperature would have been -3. But supposedly the Earth has been fairly constant temperature for all 4.6 billion years of its existence. If anything, it was warmer back then than it is today, despite the brightening sun. So what you have is the theory, and yet the evidence doesn't work. Special sun. The sun is brighter in absolute terms than most representative stars, and its mass exceeds that of most stars. The sun's luminosity exceeds that of most stars. The vast majority of stars are smaller, cooler, dimmer, and less massive. We have no definitive proof that any planets exist beside the suns, but we need a second example to feel confident that our own solar system does not represent a cosmic anomaly, a unique or nearly unique circumstance. Why? Because otherwise you're driven to the point, why then is Earth so unique? Unless there was a creator that said, this is going to be special. Cosmology problems, John G. Harnett. Cosmology is a weak form of science, at best. It relies heavily on statistical arguments and on observations that have many possible interpretations. In that sense, it is not the same footing as repeatable operational science. It cannot make predictions on that basis, because even if you do make a prediction and discover the effect you predicted, you cannot rule out many other possibilities. And some of them you may not have even thought of. So in other words, it does not, to have the results you expect does not necessarily confirm the theory that you have. Another problem here is the Big Bang is now a paradigm. It's believed to be true, and the universe started this way. So evidence found that contradicts is woven into the established fabric by an additional ad hoc hypothesis and new parameters. In other words, a constant supply of items to jury-rig, makeshift, make repairs to fix something, like a broken mast at sea, to make repairs on a failing system. The results in unknown. These result in unknowns that are used to explain the unknown. So even if you find evidence to support your unknown, what if the unknown is purely fiction? Well, you have no way of being able to guarantee that just because it does describe something doesn't necessarily mean it's real. It would not be the first time in science that such a situation is developed. Phlogiston is one such example. Phlogiston was a supposed fire element that was in such things as it would. And so when you burned the wood, it would emit this phlogiston, and that's why once the wood has been burned, all you are left with is just ash, because the phlogiston now has dissipated into the air. Well, we know that that's not true. But the thing was, for many, many centuries, that was the working premise as to what created fire. The Big Bang is claimed to be the uncaused cause, the beginning of the universe without God. Cosmic inflation is used to support that conjecture, and because of the conflicting evidence, it is necessary to be supported by unknowns. This is a deep hole that those believers in scientism have dug, and they must blithely continue, else they would have to admit the Creator. That is, we are likely very near the center of the universe, filled with billions of galaxies with billions of stars in each. This is what Edwin Hubble concluded. His observations of the Hubble telescope, his observations of the galaxy's redshifts indicated to him that we were at the center of a symmetric matter distribution. But Hubble rejected his own conclusion that we are in a very special place on philosophical grounds. And Hubble wasn't alone in realizing this situation. People need to be aware that there is a range of models that can explain the observations, Ellis argues. For instance, I can construct you a spherically symmetrical universe with Earth at its center, and you cannot disprove it based on observations. Ellis has published a paper on this. You can only exclude it on philosophical grounds. In my view, there is absolutely nothing wrong with that. What I want to bring into the open is the fact that we are using philosophical criteria in choosing our models. A lot of cosmology tries to hide that. Again, going back to the first of the topics, theory determines data. Again, open letter to the scientific community. What is more, the Big Bang Theory can boast of no quantitative predictions that have subsequently been validated by observation. The successes claimed by the theory's supporters consists of its ability to retrospectively fit observations with a steadily increasing array of adjustable parameters. For instance, dark energy, dark matter, and so forth, just as the old Earth-centered cosmology of Ptolemy needed layer upon layer of epicycles. So in other words, what was happening with Ptolemy's view was that you had the Earth at the center and the sun coming around, and then you had the planets coming around that, and then you had to have other little circles, and and so forth. It would just got to be such a process of layer upon layer of adjustments. The dissidents say that there are other explanations of cosmology that do make more successful predictions, but their development has been severely hampered by a complete lack of funding. Indeed, such questions and alternatives cannot even now be freely discussed and examined. You think that there's a problem with creationism. Even in evolution's own camp, you have people being pushed aside, silenced, because it isn't what is accepted by the popular group. Remember, theory determines data. Okay, lithium, one of the problems here is that lithium is also supposed to have been formed with hydrogen and helium in the beginning, but very, very small amounts, and what is expected is not what has been discovered. That only half of the amounts have been discovered. You have other kinds of things, other kinds of problems that we face with the idea of evolution, with the Big Bang, and all of these would have an answer, but science today doesn't want to entertain that possibility. The redshift, necessary second thoughts. Well, earlier we said the redshift indicates concentric circles, still requires a better framework. You have the Doppler effect, and you're familiar with this. As the train comes, the whistle sounds higher, and then when the train passes you, the whistle suddenly shifts sound, because as it's coming, the sound waves are being compressed, and then afterwards the sound waves are being stretched out. Well, supposedly with the redshift, you have the same kind of idea, that as the speed of light stays the same, but because if it's coming toward you, then everything would go to a higher level or higher color, and then as it goes away, it goes to a lower level. All right. Problem is that a guy by the name of Arp found that you have the galaxy, which is supposedly receding at 1,800 kilometers per second, at 107 million light years away. You have a quasar, which is supposed to be receding at 21,000 kilometers a second and 1.2 billion light years away, and yet you have clearly they're linked. So there's a problem there in terms of how do you reconcile that? Well, ARP is talking about there is these problems. I'll let you read that as we get there. The greatest mistake, in my opinion, is the one we continually make, is to let the theory guide the model. After a ridiculously long time, it has finally dawned on me that the establishment scientists actually proceed on the belief that the theories tell you what is true and what is not true. Again, you have, in his discovery, the theory determines data. You have other types of explanations for the redshift. One is the possibility that the whole universe is revolving around the center, and therefore you would have the high redshift that is observed. You have mature creation. In other words, that God created something that, yeah, it's in process. It looks like it is a universe that is already in process. And you have different things that identify, well, okay, like for instance, it takes 100,000 years for photons emitted from the core of the sun to reach its surface. If God created the world 6,000 years ago, then he would have had to create with all of this already happening. Anthropic principle, the idea behind this is that if you came across a watch on the ground, you knew that there was somebody who created that watch and put it together. Somebody who designed it. Well, what we have here is that we take a look at the universe, and you literally have bunches of, hundreds of carefully balanced equations, constants, properties of matters. Well, this seems to indicate that there was some designer who put this all together in the intricacies that we have observed so much in the sciences. And it was good. Imagine if God had to depend upon whether he gets likes as to what he does. Okay, here's the assignment. And have fun. And thank you.